Earlier today, we talked about rational numbers, so I want you to see that's at the beginning of these notes. And then we talked about radical factors. But at the bottom of this page, we're going to talk now about operations with radicals. So first, let's just take a look at why the rules are going to be the way they are for adding radicals. So if I have 2x plus 3y, 2x is technically x plus x, and 3y is going to be plus y plus y plus y. When I take a look at that, it is still just 2x's plus 3y's. But B, I have 2x's, so x plus x, plus 3x's, so x plus x plus x, and all in all, I have 5x's. I can add 2x plus 3x and get 5x's because they have like terms. So let's look at it with radicals. If I have 2 radical 5, what that really means is that I have radical 5 plus radical 5. Then plus, I have 3 radical 7, so radical 7 plus radical 7 plus radical 7. When I sit back and analyze it, that is still just 2 radical 5s and 3 radical 7s. There's no other way to describe it. Now, D, though, I have 2 radical 5s. So I have radical 5 plus radical 5, then plus 3 radical 5s, so plus another 1, 2, 3 radical 5s. When I take a look at it, I see that all in all, I have 1, 2, 3, 4, 5 of those radical 5s. So that's going to lead to our addition. In order to add radicals, we must have like radicals. I can only count up more radical 5s if I have more radical 5s to add to it. So we'll take a look here. Only terms with like radicals can be added together. So example 2, let's take a look. I have 2 radical 6's plus 5 radical 6's. So radical 6, those are like terms. So all in all, I have 7 radical 6's. 2 plus 5 is 7. Radical 7 over here is different, so it won't combine with my radical 6's. So my answer is 7 radical 6 plus 3 radical 7. B, I have 3 radical 10 plus 4 radical 3 minus 5 radical 10s. So I can see here that the 3 and the minus 5 radical 10s will combine together. So I have 3, I'm going to take away 5 of them, so I'm left with a negative 2 radical 10 and then plus 4 radical 3, which is different. Then when I get to example C, they appear different. But if I were to simplify the square root of 27, things might change. So let's take a look. Square root of 27 is going to break up into 9 and 3. So that's going to really be 3 radical 3. So now I have 2 radical 3's plus 3 radical 3's. They are like terms, and I can add them and get 5 radical 3's. All right, so our next little hint here is that you always simplify radicals before you combine like terms. Otherwise, you usually can't do it. For example, square root of 20 minus square root of 45 don't appear to be the same. But if we simplify them, let's see, we get square root of 4, square root of 5. So we get 2 radical 5's minus, this is going to be 9 times 5. So that's going to be 3 radical 5's. So I have 2 radical 5's minus 3. So 2 minus 3 is negative 1 radical 5. So you could write just negative radical 5. B, I have 3 square root of 18, so that's going to be 3. 18 is going to break up into 9 and 2, so that's going to be 3 times 3 times radical 2, so 9 radical 2. Minus 6 radical 50, that's going to break up into 25 and 2, so that's 6 times 5 times radical 2, so minus 30 radical 2. 9 minus 30 is a negative 21 radical 2. All right, so now let's do some with some fractions. I'll change colors here. Let's do some with fractions. They don't appear to be anywhere close to alike. But if you look at the square root of 6/5, I realize that there is a fraction in the radical. I need to simplify. So let's put our 4 right there. And then we have the square root of 6 over the square root of 5. To rationalize it, we'll multiply by the clever 1, square root of 5, over square root of 5. And so we get this. 4 times square root of 5 times square root of 6 is going to be the square root of, oh, there it is, 30, over square root of 5 times square root of 5 is 5. So that is, oops, a little bit. That's going to be then, notice the 5 is in the denominator, so this is going to be 4 radical 30. I'll put 4/5. Let's do it this way. Let's do 4/5 times radical 30. So I'll just make my fraction out front like a coefficient because it's not inside the radical. And then in front, I'll just recall that I had the square root of 30. So now I do have the same radical, and I need to add them. This has got an understood 1 in front, right? So that's going to add to be 1 4/5 times the square root of 30. And I don't really want to put 1 4/5. I'm going to change that to an improper fraction and make that 9/5 square root of 30. All right, D. Same situation, a little bit different. We're going to need to simplify this second radical here. However, this time, we can, when we simplify it, the square root of 10 over the square root of 49, the square root of 49 is 7. So I have the square root of 10 over 7. So let's bring this down. So now I have the square root of 40 plus, I'm going to write this again as a coefficient. So that's 1/7 square root of, oops, 10? Oh, well, that's a problem because square root of 40 hasn't been simplified, has it? So let's just go back and do a little in-between step there. 40 is going to be 4. Square root of 4 to the square root of 10, so that's going to be 2 radical 10. Now, that's a little better. So we want to add them. Now we have the like radicals. We're going to add them and get 2 and 1/7. So I'm going to multiply. That's 14 plus 1 is 15/7. So that's going to add to be 15/7 radical 10. All right, so now take a minute, stop, take a minute, quit listening to my voice, and work these 3 problems, and then come back and check and see how you did. Okay, so now hope you're back and you're now checking and seeing how you're going. If you find at this place that you have a question of why, jot it down right now, put a circle around it, and have me take a look and explain it again next class. I'll be glad to do that, and somebody else may have the same question. All right, the next topic we're going to cover is about multiplying binomials. So recall that when we multiply 2 radicals, the inside is going to be multiplied times the inside. Also, the outside would be multiplied times the outside, also inside and outside for that. So when I multiply here, I'm going to distribute. So I'm distributing for this one. And when I distribute, the square root of 2 times the square root of 2 is going to be the square root of 4. And the square root of 2 times the square root of 5 is going to be the square root of 10. So notice inside times inside for both of those. Square root of 4 is 2, so we can simplify that. And square root of 10 is as low as it goes. B, we have square root of 6 times square root of 3 is the square root of 18, minus the square root of 6 times the square root of 2 is the square root of 12. Once we multiply, we always need to look to see if those radicals can be simplified. So this will break up into 9 and 2. So this is a 3 radical 2. And radical 12 will break up into 4 and 3. So that's going to be 2 radical 3. And again, answer, and they don't combine because they're not like terms. Well, here's some fractions. It's always fun, fractions. When we add, there's a couple things going here. One, I noticed that there are radicals in the denominator, so those will have to go. And I know that when I add fractions, in order to add fractions, I have to have the same denominator. So we're going to have to get a common denominator for these as well. So it doesn't really matter which order you do these in. I will start off by rationalizing those and get rid of those radicals in the denominator. So I'll start here, square root of 2, square root of 2, multiply by the clever 1, make this be square root of 2 over 2, plus the second one, I'll multiply by radical 3 over radical 3, and that's going to give me 2 radical 3 over 3. Okay, rationalized, check that box. So the next thing we want to do is to get the common denominators. I have a 2 and a 3, and I need a 6. So clever 1 again. To change my 2 here, I'm going to multiply by 3 over 3. So that'll give me that 6 in the denominator, and my numerator will be 3 radical 2. For the second fraction, I want a 2 and a 2 to give me that 6 in the denominator, and then outside times outside is going to give me 4 on the outside, radical 3. So notice the 2 is going to be multiplied just times the front of that. So 2 times 2 is 4, radical 3. Now I'm ready to add, keep the denominator, add the numerators, and there's nothing much we can do with those except write 3 radical 2 plus 4 radical 3. D, different looking, but still the same situation. So I'm going to break this up and say square root of 2 over square root of 3 plus square root of 3 over square root of 5. Let's go about it the same way. So rationalize. So we'll do square root of 3, square root of 3 here. Inside times inside on this one, it gives me square root of 6. And the denominator square root of 3 to the square root of 3 is 3. Then plus over here, radical 5, clever 1. And that gives me, again, inside times inside is the square root of 15 over 5. Common denominator is going to be 15. So clever 1 with a 5. That's going to give me a 15. And then front times, outside times inside, that's going to be 5 radical 6. Right here, 3, clever 1, that's going to give me a 15, and that's going to be 3 radical 15. Again, outside times inside, they don't mix. Add them, keep that 15 denominator, and then I have 5 radical 6 plus 3 radical 15 for my final answer for that. All right, so that was just, we did some distributing, adding fractions. Now we're going to multiply binomials. So you could call it FOIL. You can FOIL it. That's actually also the same thing as a double distribute. Or you could use this divided box. I know a lot of you like to do that, and that is fine as well. Why don't I start this one by doing the divided box? So I've got my box. I'm multiplying 2 binomials. So I have 5 minus radical 3. And here I have 3 and then 2 radical 3. So let's multiply 3 times 5. So 3 and 5 is going to give me 15.
3 times a negative radical 3, it's negative. I have an outside and an inside, so that's going to look like this, negative 3 radical 3. Then down here's the 2 times the 5. The 5 and the 2 are outside, so that's 10 radical 3. And then my last 2 terms here, a positive times a negative is negative 2. And then radical 3 times radical 3 is plane 3. So that's actually going to be a negative 6 right there. So when I add them together, I have 10 minus 3, so that's 7 radical 3. And then I have 15 and a negative 6, so that's going to be a positive 9. All right. So B, I have to square that. So remember, anytime you square binomials, you need to remember to FOIL it or double distribute or whatever. So I'm going to go ahead and write it separately to emphasize that. So I'm going to multiply, I'm going to double distribute 4 radical 2 times this one, 4 radical 2 plus 3, and then plus 3 times 4 radical 2 plus 3. So I'm going to double distribute that, which is the same as FOIL. And that's going to give me, 16 times 2, and then plus 4 and 3 are outside, so that's 12, then radical 2, plus 3 and 4 are outside, so it's 12 radical 2, and then 3 times 3 is positive 9. So I end up with 32 and 9, that's 41, and then 12 radical 2 is going to be 24 radical 2. Okay, one last one, next page. Again, multiplying this out, maybe this time do it in your head. I'm going to again double distribute, so I'm going to take the 4 times this whole thing. So it's going to give me 16 minus 4, it's going to be a minus because positive, negative gives me a minus. Outside, inside, so it's 4 radical 7. And then come here to the next one, so here, and multiply it times this as well. So this time it's a positive 4 radical 7, and then minus 7. So combining, I get 16 minus 7, that's 9, and then that comes out to be 0. So my answer is 9. So notice I've got a 9, have no radicals left. So this next green box talks about conjugates. And letter C, the 4 plus radical 7 and the 4 minus radical 7 are actually called conjugates. For them to be conjugates, they've got to have the same 2 numbers in them. So they both have a 4 and they both have a radical 7. And the sign in the middle, just the sign in the middle, must be different. And you see that. And the nice thing about radicals, or conjugates, is that when you multiply conjugates, you lose that radical. All of a sudden, you just have a nice, pretty 9 for your answer, which is often a goal. All right, so here, green box, to rationalize the denominator with a binomial containing a square root, multiply the numerator and denominator of the fraction by the conjugate of that expression. So first, let's talk about conjugates. You can see first example here, you've got 2 plus radical 5. Its conjugate is 2 minus radical 5. Notice the sign in the front doesn't change, just the one in the middle. Okay, so think ahead a little bit. For square root of 7 minus 1, its conjugate, think in your head, is going to be square root of 7 plus 1. Just change that middle sign. Square root of 6 plus square root of 7. That's right. It's the square root of 6 minus the square root of 7. So those are conjugates. That is a concept you will use from this point on in math, not only with radicals, but with in other situations as well. All right, so for example 6, let's use conjugates to simplify and get that radical out of the denominator. If I were to just multiply by the square root of 5 as a clever one, when I distribute, I would still get a radical when I distribute it right there. So just multiplying by that square root of 5 in this situation will not work. So what you're going to have to do is multiply by the conjugate of the denominator. So conjugates, square root of 5 plus 1, opposite sign. Remember, always opposite sign. So then I need the clever one. So to get the clever one, I have to have exactly the same thing in the numerator. So square root of 5 plus 1. Then I am going to multiply the 1 times the numerator. So that's just still the same thing. Square root of 5 plus 1. And then I'm going to multiply the denominator. So when I multiply that, however you want to multiply it, look and see what happens. So I'm going to do square root of 5 minus 1, square root of 5 plus 1. Notice they have the opposite signs in the denominator. So that gives me square root of 5 times square root of 5 is 5. Square root of 5 times negative 1 is negative radical 5. Bottom box 1, so that's a positive radical 5. And then positive 1 times negative 1 is minus 1. My radical 5s, one's positive, one's negative, so they make a 0. So I end up with 5 minus 1 is 4. No radicals there now, and that's the answer. There's nothing I can do to simplify that anymore. I think we have at least one more example here. So this time I'm going to multiply through by the conjugate again of the denominator. So this time it's going to be 1 subtract radical 3, conjugate. Then clever 1, exactly the same thing in the numerator. Distribute. Oh, I'm not going to distribute, and I'll show you why in just a minute. So the smarter thing to do here is just to leave that 6 in the front, and then 1 minus radical 3. So I'm just going to leave it written that way. I'm going to FOIL the denominator, and when I do, I got 1 radical 3 and 1 minus radical 3. So that's going to give me a 1, a radical 3, a negative radical 3, and then a negative times a positive is negative. Radical 3 times radical 3 is 3. So my radical 3's, one positive, one negative, undo each other, and I end up with 1 minus 3 is negative 2. Now, we won't get to fractions until the next unit, but I still want to teach this right. What I want to do here is I need to reduce, and I need that 6 out front in order to do it. So I'm going to reduce that 6 and the negative 2. So 6 divided by negative 2 is negative 3, and then 1 minus radical 3. Now I'm going to distribute it, and I'm going to come up with negative 3 plus 3 radical 3 for my final answer for that. All right, I believe that there are some practice problems next. So again, stop it, give it a try, check your answers, make note of any questions that you've got. All right, so here you are again. Take a look. Again, take notes and see, and let me know if you have any questions over this. So, see you in class.